geometry, we are finally moving on to done with simplifying roots, although now, forever and ever and ever, when you get a root as an answer, you'll be expected to put it into simplest form, because now you know how to do it, okay? But we're moving on to the operations involved in roots. Just like when you learn about fractions, you first learn how to simplify fractions, then you learn how to do the operations with them, knowing your answer would need to be in simplest form. Same idea here, okay? Here's the good news about roots, because if you look at what's on this page, it looks, especially when you kind of get to the second page, pretty intimidating. Okay, we got variables involved, we got multiple roots, we got all these things. How roots interact with each other is exactly the same as how fractions interact with each other when it comes to addition and subtraction. What do we know about the fraction 5/8 plus 2/8? Can it be added the way it's written?
Yes.
Yes. Why?
They have a common denominator.
Because the denominators are the same. And when you do the addition, what gets added?
5 plus 2.
The 5 plus 2. What stays the same?
The
So what would the answer to this one be?
7/8.
7/8. If we had the root expression, 5√8 plus 2√8, it's the same thing. In order to add and subtract roots, the radicals must be the same. And when you do the addition or the subtraction, the roots don't change. Only the coefficient does, how many of them you have, right? Remember, a coefficient tells you how many of something you have. We have 5√8s. We get 2 more √8s. How many √8s do we have? 7. Does it become 7√16?
No.
No. Okay? Just like this didn't become 7/16. Right? Same idea. Same idea. The roots must be the same and they stay the same. Okay? Let's say we've got 3/5 plus 7/10. Can that be added the way it's written? No. What do you need to do in order to be able to add them? Yeah. The second one, 3/5 plus 7/10.
You multiply 3/5 by 2/2 to make the denominator 10.
Right, you have to make the denominators the same. Okay? The same is going to be true with roots as far as making them the same. However, it's not quite the same process as a fraction is. In order to make roots the same, like if we had 3√5 plus 7√10, I could not multiply this by 2 to get a √10. The reason why I can't do that is because when I multiply 3/5 by 2, what am I really multiplying by?
1.
I'm really multiplying by 1. If I multiply both the numerator and the denominator by the same thing, I'm not changing the value. If I double this to get 6√10, is 6/10 a different value than 3/5?
No.
Yes. So I didn't multiply by it by 1. I multiplied by 2. Okay? This only works with fractions because of what anything divided by itself means. So in this case, I can't go any further. I'm done. I stop. Answer. Final answer. If the roots are not the same, and you cannot get them the same by simplifying, that's why we spend so much time on the simplifying part. There's nothing more that you can do. This would be the end. Okay? Okay? Let's look at the next one here. What would we do with fractions to be able to subtract these?
Multiply. You can get the same denominator.
Get the denominators the same.
Can't you flip the equation?
No, that's for division.
That's for division, yeah, okay.
If this were roots,
So what, times 3.
8√9 minus 2√27. Again, I cannot multiply this by 3 because that's going to change the value. I'm literally multiplying by 3. That changes the value. It's not multiplying by 1, but I do need to simplify this. So, how does 8√9 simplify to be? How does 8√9 simplify to be? Yeah. 24. And how'd you get that?
Root of 9 is 3.
Root of 9 equals 3.
8
And so 8 times 3 is 24. Excellent.
Oh.
How does 2√27 simplify? You can. What? Yeah. So this would break up into root 9 times root 3. Right? The root 27, 9 times 3, 9 is that perfect square. The 9 becomes a 3. The 2 times 3 combines to give me 6. The root 3 I can't do anything with. And so my final answer for this one needs to be 24 minus 6 root 3. It needs to be in simplest form. So you can't always get the like roots to actually combine them. You can only do that with simplifying. Here we simplified. We didn't get them. That's okay. We still have to write our answer in simplest form. Sam.
How do you get on the first half, the 8 and the 9 and the how do you get the 3 out of it?
The root of 9 is a perfect square. It equals
Oh, yeah,
3.
27.
27 is 9. Yep. Okay. You can also think about roots as variables. You have 4 x's and 10 x's. How many x's do you have? 14x. Just like if you had 4 root x plus 10 root x, how many root x's do you have? 14 root x. There's your final answer. 12n minus 7n, how many?
Country team members, please come down to the office to get your uniform. Thank you.
12 n's, folks. 12 n's minus 7 n's, how many n's do you have? 5 n's. If you have 12 root n minus 7 root n, your answer is going to be 5 root n. Right? Sure. You can do that because the roots are the same, right? You've got both with root n's. You have 12 of them, you subtract 7, you're left with 5. Okay? The last one, are 6x and 2y like terms?
No.
So can you do anything with that expression? No. If you had 6 root x plus 2 root y, could you do anything with that? No. Okay? So if you kind of combine the idea of fractions and common denominators with the idea of combining like terms, that's all there is to adding and subtracting roots. They just look more complicated because not a lot of people understand roots or how to simplify them. But you do. Okay? Maddie.
So the 6x plus 2y, would you write that as final answer or no?
Final answer. Yeah. Okay. Yeah.
Did you forget to do the homework, like the rest of the homework on the last page?
No, we talked about the rest of it. We only had like 3 of them to work on.
What if you didn't go
I did.
I think maybe
Okay. A little bit of practice here.
really hard.
3 root 5 plus 8 root 5. Let's run through our checklist. Are the roots the same?
Yeah.
Yes. If you have 3 root 5s, get 8 more root 5s. How many root 5s do you have? 11. Root 10?
Root 5.
Root 5. Right? The root does not change. Like the denominator of a fraction, like the variable with combining like terms, the root does not change. Yeah. We will get through all of them, yes. Next one, 12 root 7 minus 9 root 7. Are the roots the same?
Yes.
You have 12 of something, you lose 9. How many do you have? 12 minus 9 is 3 root 7. Not root 0, right? The root doesn't change. 3 root 7. 10 root 10 plus 13 root 10. Are the roots the same?
Yes.
We're good to go. How many root 10s do we have in all?
26.
23 root 10s. Okay? Yes?
I wanted to do that one.
Which one?
The
The 4th
fourth one.
one? The roots aren't the same, are they?
No.
No.
Can we make them the same?
No. No.
Andrea, can we make them the same?
No.
No, you cannot. Charlotte? Sam? Okay? Since we cannot make the roots the same, we're done. That's our final answer.
You're done.
Nothing more we can do. Yes, Andrea? Oh, sorry. Would you like to?
No,
Andrea, anything more we can do?
no, this is your final answer.
That's your final answer. Okay? If you cannot get, sorry. If you can't get the roots the same, then that's all you can do. Next one, 11 root x minus 2 root x. Are the roots the same? How many root x's do we have? 9. 9 root x would be our final answer. Okay?
Woohoo.
Are we getting the hang of this a little bit?
Yes. A little.
In the 3 minutes we got left, any questions I can answer? Nathan.
So for like, basically the first one on that one, which is basically the same question I was gonna ask for the fourth one. You can make them the same, right? If you just did 4 and 2.
Which one are you talking about?
The first one on that.
The one we haven't done yet? Yeah. Folks, let's look at the first one under the Mr. Happy Pencil section here. 5 root 2 plus 4 root 8. The roots are not the same. However, Nathan, what can we do here that will actually end up making them the same? What can we do here that will actually end up making these the
Oh, you
same?
simplify 8 though.
Yeah, root 8 can be simplified, right? Root 8 can be simplified to be 4 times the root of 4 times the root of 2. This is where that simplifying is so important. It's used everywhere else with roots. Okay? Edward, you following? Getting this down?
Yes, sir.
Why are we leaning so close to brakes? Just back up a little bit.
Whoa.
There you go. Okay?
Yeah.
So, root 4 being the perfect square, we have 5 root 2 plus 4 times 2 root 2. This becomes 5 root 2 plus 8 root 2.
Wait, come again?
Yes.
I got it.
I can't even see.
Simplifying root 8
Oh,
being 2 root 2.
Oh, yeah.
We get 5 root 2 plus 8 root 2. Can we add those now?
Yeah.
Yes. 5 root 2 plus 8 root 2 gives us 13 root 2 as a final answer.
I got it.
Okay? Why we spent 3 weeks simplifying roots and why we went over and over and over and over them is because you need them for this. Okay? You need them for this. All right, no homework for tomorrow.